This function, it's got a logarithm. And so one thing we want to look out for is that we have a vertical asymptote when the argument of the logarithm equals 0. And then we can't have negative values inside the logarithm. And the reason for that is a logarithm says, hey, what power, right now this logarithm has a base of e. So a logarithm, a logarithm says, what power do you raise the base e to make it equal x to the third minus 1? Okay, so let's pretend like we plugged in a number for x. Here, this is the question. We want to know what this power is up here, this blank. And so let's pretend we plugged in a number for x and we got out -1. So what power do you raise e to make it equal -1? Can you put a number in for the exponent to ever change it from a positive number, 2.7, whatever e is? Can you put a number in the exponent to turn it into a negative? You can't, right? There's no, negative exponents just shrink the number. It doesn't change it from positive to negative. So that's why we can't have negative values inside the argument of a logarithm. So the domain, I'm looking at the argument of the logarithm, the x to the third minus 1, and I want to find out for where that's greater than 0. And it's not greater than or equal to 0 for where it's greater than 0. Because if we have exactly 0, that's where we have a vertical asymptote. Okay? Because again, the question is like, what do you put in for y to make e equals 0? There is no number. Okay, so to solve that inequality, add 1 to both sides. You'd want to use the cube root to both sides. For this one, you're going to get x is greater than 1. Let's see, and that's it. That's it. So interval notation would be 1 is the lowest, and then positive infinity is the highest. So the vertical asymptote happens, like we just said over here, as y goes to, let's see, negative infinity, then e to the a power that approaches negative infinity would equal 0. So that's why we have an asymptote happening here, because you get a really small negative number, then you could make it approximately equal to 0. So the vertical asymptote, in short, happens when the argument equals 0. So if you were to solve this equation, you would have the vertical asymptote. Okay, but we kind of already just did that up there. That's when x equals 1. That's where the vertical asymptote occurs. Now these last two questions, as x approaches the vertical asymptote, it's saying g of x, oh sorry, it's supposed to be f of x, because I called mine f of x. It's asking what's happening with f of x as the x values get closer to the vertical asymptote. In other words, it's saying what are the y values as we get closer to the vertical asymptote. We said the vertical asymptote is at x equals 1. So how about a number slightly to the right of the vertical asymptote? Let's check out x equals 1.1 in our calculator. And then we'll check out something even closer. We'll check out what happens to the y values in x equals 1.01. Notice I can't do x equals 0.9 because I don't have a negative inside the argument of the logarithm. Okay, so if we plug in 1.1, and if we cube it, there it is cubed, subtracted by 1, then take a natural log, and then add 10 to it, we get 8.89. So we plugged in 1.1, we got out 8.89. Let's plug in something even closer, and then cube it, subtracted by 1, take the natural log, add 10. We got smaller, right? So let's plug in something really close to the vertical asymptote. If I cube this, take a logarithm. Oh, no, sorry, I got to cube it, subtract by 1 first. So here, there's a number really close to our vertical asymptote. Subtract that by 1, logarithm, add 10. We got a negative number, and you'll be able to see a pattern. The closer you get to the vertical asymptote, the smaller the numbers gets, going towards negative infinity. And you could see that if you were to graph it too. But negative infinity is what's happening with the y values as we get closer to the vertical asymptote. If you were to sketch this graph, it would look something like this. At x equals 1, it's actually undefined, but right before you get x equals 1, we're having a vertical asymptote. So here, I should draw x equals 1 right here. That's more accurate. Going towards negative infinity for the y values. And then they say, what happens to the y values as x approaches positive infinity? So if you were to look at this graph, it looks like it levels off, but something we study with logarithms is that they never stop increasing. So as x goes to positive infinity, it's slowing its rate of increase, but it never stops increasing. The y values keep going up. So as x approaches infinity, the y values, they do go to positive infinity.